Now we will see these examples as applications on the square functions and square root functions and their transformations using GeoGebra activity. The square function, the basic parent function, which is f of x equal x squared, which is in the red curve, and we have another function g of x, which is x minus 4 squared plus 2. Or simply we can redefine it as f of x minus 4, since f of x minus 4 will be x minus 4 squared plus 2. According to the rule, the translation vector will be 4, 2, which is minus ab. Here a is 4 and b will be 2, so the translation vector will be 4, 2. Thus we can deduce that the graph of the function g will be the same as, has the same form as the curve of f, but translated by this vector, which is 4, 2, as you see. So the curve of g will be the blue one, and this is the translation vector. If we change the value of a, you can see that the curve of g will be changed, and here the translation vector of is 0, 2, and we have 2 units up for the curve of f. So this is the curve of g, will be, which is an image of the image of f. Also, if we change more and more the value of a to get different position, see if we change the value of, let's make a 0 value, and b, let's change it, which is 2 now it will be 1, and now they are confounded, as you see, and from the formula g of x equal x squared, which is the same as f of x for all x, thus their curves will be confounded. Look, if we change the value of b, it will be f of x minus 2, so we drop down the curve 2 units. For 5, so we push it up 5 units to get the curve of g. This is the main idea of square root function. Let's see for the square root function. This is the basic square root function, which is p of x, which is square root of x, the red one. If we are given another function h of x, which is equal to square root of x plus 3 plus 1. As you see, we have a square root, so the curve of h will be square root function, but with a little translation. How can we deduce the translation? It's simply h of x equal, in fact, p of x plus 3. In fact, this is p of x plus 3. This is p of x, and p of x plus 3, it will be radical x plus 3 plus 1. So the translation vector, the main point, the first point you have to find the translation vector, it will be minus a, this is the value of a, and this is the value of b, minus ab. So we have to, we can deduce the graph or the curve of h by translating the curve of b by a vector minus 3, 1. So we go minus 3 units to the left and 1 unit upward to get, and we start drawing the curve of h similar to the curve of p, as you see. Even if we change the value of a, you can see that the translation vector is changed. If we change the value of b, as you see, the role of b translates the curve upward and downward. For positive value we go upward, for the negative value we go downward, while the values of a, for positive values we go to the left, and for the negative values we go to the right, as you see. Okay, this is it. These are applications on square function and square root function. What about the transformation of absolute value function? It will be, as we saw before, the absolute value function has this form, this one, the red one. It has 2 semi-straight lines connected at the 0, at the origin. g of x, it is absolute value of x minus 3 plus 1. As you see, you can easily deduce that g of x equal f of x minus 3. In fact, this is f of x minus 3, since f of x equal absolute x, so absolute x minus 3 it will be f of x minus 3 plus 1. So you can easily notice that the translation vector in this case will be 3, 1. So we move 3 units to the right and 1 unit upward to get, and at this point we have the vertex, the minimum point of the curve of g, which is in fact a translation, it's an operation of translation of, or transformation of the curve of f. Even if you change the value of a, as you see, the translation vector changes 7 to 1, 7 units up to the right and 1 unit up. If we change the value of b, 7 minus 2, it will be 7, not minus 7, and we take b as it is, it will be 7 minus 2, 7 units to the right and 2 units downward, and this is it. In fact, we work in the same manner as we worked before in the square function and the square root function. The last function, which is transformation of inverse function, which is an odd function as we saw before. F of x equal 1 of x, the red curve represents the basic, the parent function, and other functions such as g of x equal 1 over x minus 1 plus 1. It will be in fact an inverse of x minus 1, so you can easily deduce that this is f of x minus 1. Since f of x equal 1 over x, so this represents, this part of this function represents f of x minus 1. So the translation vector will be 1, 1. 1, 1, it means that we move this curve 1 unit to the right and 1 unit to the upward to get the this part, and similarly this part is translated by 1 unit and to the right and 1 unit upward. See if you change the values of a, as you see here, let's say 1 over x minus 4 plus 1, so the translation vector will be 4, 1. So we move the red curve 4 units to the right and 1 unit upward. I advise you to choose these 3 points, this 1, 1, and move it translated by 4 units by the translation vector, which is 1, 2, 3, 4, and 1 unit upward to get this point. After that, choose this point, 2 half, and half 2. Translate these 2 points to get these 2 points by this vector to get at the end, join them to get the curve of g of x. And if you change the values of b, you can easily notice that the curve of g is still the same as the curve of f, but with a certain translation, and your mission is to find the translation vector correctly in order to draw the curve in a true way. Well, this is it, and thank you for watching this video.